omega 2 by omega 1, right? Now we need ratio of omegas. So to find the ratio of omega, we can find the ratio of time period. Omega 2 is 2 pi by time period of second one, and this is 2 pi by time period of first one. So that is T1 by T2. And what is T1 by T2? Time period is related to spring constant like this, 2 pi under root m by k. So they are having equal masses also. So we can say time period is inversely proportional to k, right? Root k. So T1 by T2 will be root of K2 by K1. And our answer will be D. Is that clear to all? Is that clear to all? Moving to next question. Next, the period of oscillation of a simple pendulum of length L suspended from the roof of a vehicle moves without friction down on an inclined plane of inclination alpha is given by. So he's asking ki we have to find the time period of a pendulum. That pendulum is suspended to a vehicle, and that vehicle is like going down on an inclined plane, and again there is no friction. And now our pendulum, our bob is hanging over here. So this is our bob, जिसका हमें time period निकालना है. This is alpha, angle of inclination is alpha. Now there are two methods to do this. First you find the acceleration of car, and that is G sine alpha in this direction. Now think about pendulum. What is the formula for it? 2 pi under root L by G, right? And G, which G we use? G effective. So for pendulum, I'm just making free body diagram. So in this diagram, in this direction, G acceleration is there, and I'm applying MA also. MA is in this direction. That is like pseudo acceleration or pseudo force. So it is G sine alpha direction. Now you find resultant of these two, and eventually you will get G effective, right? So this is alpha. This is again alpha. So I can say this angle is 90 minus 90 plus alpha, and you find the resultant of these two. So G effective will be under root G square plus G sine alpha whole square plus 2AB cos theta. So 2G into G sine alpha into cos angle between them, 2AB cos theta, cos of 90 plus alpha, which is minus sine alpha. So that gives me G square plus G square sine square alpha minus 2G square, and this is sine alpha into sine alpha, and minus I have already used over here. So it is again sine square alpha. So that makes G square sine square alpha minus 2G square sine square alpha. So this cancels out, and here we'll get a negative. So G square I'm taking common, and it is out 1 minus sine square alpha, and that is cos square alpha. So you get G cos alpha. So effective G will be G cos alpha. So this is the answer. A will be the answer. Is that clear? Is there any confusion? Now if you इतना सब नहीं करते तो भी चल जाता. See, G को just split करो again. तो G को split करेंगे तो हम लोग करेंगे G sin alpha में, and यहाँ पे G cos alpha में. And again ये sin alpha और ये pseudo वाला cancel हो जाएगा. Effective is G cos alpha. So that is even faster. I will re-explain वापस. We have to find G और G sin alpha वाला. So इसके बस दो component कर दो. So it will be G sin alpha and G cos alpha in this direction. And eventually these two will cancel out और ये बच गया. तो ये answer है. Next one. This one. A particle executes simple harmonic motion between x is equal to minus a to plus a, standard case. The time taken for it to go from 0 to a by 2 is t1 and a by 2 to a is t2. So we have to find which one is greater. See, just write x is equal to a sin omega t. Now just put, हमें टाइम फाइंड करना है तो x की वैल्यू फाइंड कर दो. तो दिस इज लाइक एट t is equal to 0, it is at t is equal to 0, it is at x is equal to 0. Now start putting the values. So put the value of x is equal to a by 2. So what do you get? Is equal to a sin omega t. तो यहाँ से a cancels out, omega t is 30 डिग्री, that is pi by 6. So omega t is equal to pi by 6. यहाँ से टाइम की वैल्यू आ गई pi by 6 ओमेगा. And 0 to pi by 6 omega, तो time period t1 is nothing but pi by 6 omega. Now take second value. So हमें पता है already time कितना लगेगा, complete time period, that is 2 pi by omega, that is the complete time period. And x is equal to 0 से लेके a तक जाने में, this is 1/4 of the time period, so that is t by 4. So t by 4 comes to be pi by 2 omega. And just subtract this time, so you will get t2. So t2 is nothing but pi by 2 omega, that is 0 to a minus 0 to a by 2, that is pi by 6 omega. So you take LCM as 6 omega only. So this is 3 pi minus pi, that is 2 pi. So this is 2 pi by 6 omega, and that is t2 is 2 pi by 6 omega, and that is just pi by omega. So t2 is greater. So option A is answer. There is another common sense answer set. See, what we can do is, let's just think about SHM. So this is 0, this is A, and this is minus A. When particle is over here, it is traveling with maximum velocity, right? Vmax. And when it is over here, velocity is 0. So can I say कि velocity is gradually going down when it is moving from 0 to A? Like origin to one positive x-axis, speed is always going down. And if you just half, displacement in this duration is a by 2. Displacement in this duration is also a by 2. Now here it was always traveling with a faster velocity, right? It was always traveling faster in this duration. So that's why time taken in this duration will be less than time taken for the other duration. Because like distance traveled is same or displacement is same, and speed is greater in first half. So you can say time period will be less. Is that clear? If we only have to compare, then we can use this also rather than finding actual answers. Is it clear? Here we just need to compare, so there is no need to find all the answer. Like value निकालने की कोई जरूरत ही नहीं है. Let's move to next question. Next question is, the displacement y of a particle executing periodic motion is given by y is equal to 4 cos square t by 2 sin 1000 t. This expression may be considered as a result of the superposition 2, 3, 4 और 5 independent हार्मोनिक मोशंस. तो पहले इसको स्प्लिट करना पड़ेगा डिफरेंट हार्मोनिक मोशन में. तो दिस इज पूरा मैथमेटिक्स का है, तो हमें ट्रिग्नोमेट्री यूज करना है, एंड वी हैव टू स्प्लिट इट इन एज मेनी डिफरेंट पार्ट्स एज वी कैन. सो पहले फर्स्ट थिंग इज दिस cos स्क्वायर t by 2. तो टाइम आई एम यूजिंग दिस फॉर्मूला cos स्क्वायर थीटा 1 minus 2 cos square theta is equal 2 cos square theta minus 1 is equal to cos 2 theta. So here basically cos square theta is cos 2 theta plus 1 by 2. So यहाँ पे I am splitting this. This can be written as cos t plus 1 by 2, and this into 4 into sin 1000 t. So here this is cancelling and this is 2. Now multiply this. So this is 2 cos t sin 1000 t plus 2 into 1 into sin 1000 t. So that is 2 sin 1000 t. Now this is a simple harmonic motion. तो इसको separate रखते हैं, इसको और split करते हैं. So जब इसको split करेंगे तो this is 2 cos a sin b. That is sin a plus b into sin a minus plus sin a minus b. So that is sin of a plus b, that is t plus 1000 t. So 1000 t plus sin a minus b. So this is sin 1000 minus 1, that is 999t plus 2 sine 1000t. Now all three are different because सबका omega different है. So y is considered to be made up of three simple SHM or three harmonic motions. Is there any confusion in this? This is three SHM are combined together. Is there any confusion? See, it can't be splitted further, right? We got the simplest one. Just always try to split in sine cos different terms. ट्रिग्नोमेट्री फॉर्मूला कौन कौन सा यूज किया है? एक तो ये वाला यूज किया है, देन दूसरा फॉर्मूला मैंने ये यूज किया है, साइन ए प्लस बी प्लस साइन ए माइनस बी इक्वल्स टू साइन ए कॉस बी प्लस कॉस ए साइन बी, एंड सो दिस इज 2 साइन ए कॉस बी. ये वाला फॉर्मूला यूज किया, एंड हियर ए वाज 1000t and b was just t. Is that clear? Okay. So always just split करना है, that's all. पूरा trigonometry है, physics का कोई major part है नहीं. You have to split in as many possible equations as you can. Next question. I'm moving to next part. A uniform rod of length L and mass M is pivoted at the center. Its two ends are attached to two springs of equal spring constant K. तो इसका spring constant is K, इसका भी K है. The springs are fixed. The springs are fixed to rigid supports as shown in the figure. As the rod is free to oscillate in the horizontal plane, the rod is gently pushed through a small angle theta in one direction and released. Frequency of the oscillation is, so let us just rotate this by theta. तो यहाँ से मैंने theta से rotate किया है, and this length is how much? So this total length of the spring rod was L, right? So this is like L by 2, and this is theta, and where theta is very small, so this distance is almost a straight line, and it is r theta, so L by 2 theta. And spring will try to push it with a force, pull it with a force kx, and kx is L by 2 theta. Similarly, this spring will also try to pull it back with kx force, and x is L by 2 into theta. And if you check the net restoring force, I'm just writing net restoring force, is in this case it is a rotation. Let's not write the force, let's just write restoring torque. So restoring torque, both the forces are trying to pull it in same direction. So restoring torque is force into perpendicular distance. Here perpendicular distance is also L by 2. So L by 2 into force is K into L by 2 into theta. And again you just do twice of it because both are trying to turn it in the same direction. So this is restoring torque. ये 2 cancel out हो गया, it comes to be K L square theta by 2. So just a second, this is my restoring torque. Once you write restoring torque is equal to, you write I alpha, you can write a minus over here also, it's completely your choice, and then I alpha I into alpha. हम लोग alpha को लिख लेंगे omega square theta, and I moment of inertia. See, we are able to see that it is rotating about this point. So moment of inertia of a rod, so mass m है तो ml square by 12 about the center. ये हो गया moment of inertia is equal to k l square theta by 2. Simplify करना शुरू करो. Theta is gone, l square is also gone, ये 6 हो जाएगा. So that is omega square comes to be 6k by m. Now ओमेगा मिल गया हमें, ओमेगा इज अंडर रूट 6k by m, एंड यहाँ से हमें फ्रीक्वेंसी चाहिए, तो फ्रीक्वेंसी 2 pi f is equal to omega, तो फ्रीक्वेंसी इज omega by 2 pi, और यू कैन से इन रिवर्स ऑफ टाइम पीरियड, इट इज 1 by 2 pi टाइम्स ओमेगा विच इज अंडर रूट 6k by m. ऑप्शन चेक कर लेते हैं. सी. इज देयर एनी कंफ्यूजन? यू कैन आस्क. Is it clear? क्या क्या किया, उसको थीटा से रोटेट किया, रिस्टोरिंग टॉर्क लिखा, उसको आई अल्फा लिख दिया, दैट्स ऑल। उससे ओमेगा आ जाता है, टाइम पीरियड या फ्रीक्वेंसी जो भी निकालना है वी कैन फाइंड आउट। सेम प्रोसेस, दिस टाइप ऑफ क्वेश्चंस आर कॉमन। इज देयर एनी डाउट? आई एम मूविंग टू नेक्स्ट क्वेश्चन. This one. A uniform cylinder of length L, mass M, having cross-sectional area A, is suspended with its length vertical from a fixed point by a massless spring such that its half is submerged in a liquid of density rho at equilibrium position. So it is suspended. So this is the roof. यहाँ पे suspend कर लेते हैं, and there is a spring. Then half of the cylinder, cross section area is A. So half of the cylinder is already submerged in the water. So basically buoyant force and spring का जो kx है, like kx naught, initially it is already stretched to a certain position, they are balancing mg. Now यहाँ पे density rho है, mass m, length l. Okay. Mass m, length l, and cross section area capital A. Now when the cylinder is given a small downward push and released, it starts oscillating vertically with a small amplitude. If the force constant of the spring is k, then the frequency of oscillation of the cylinder is, again frequency पूछ रहा है, same चीज करना है. Let us say let's give a small push by x. So when I give it a small push, it goes further down, and there is additional buoyant force and additional kx. So these additional forces are restoring force. Buoyant force additional is rho g, buoyant force is rho vg. So rho is into x into g. So this buoyant force and this kx are additional restoring force. So I'm starting from here. F restoring is equal to, you just write minus of their addition or just their addition, kx plus rho a x g. That is, and what can we write about F? F is mass into acceleration. Mass, acceleration is minus omega square x, right? If it is SHM, is equal to minus of kx plus rho a x g. Cancel out करना शुरू करो. So minus cancelled, x cancelled with all the x. Now omega square comes to be k plus rho a g divided by m, and this is omega square. So आपको ओमेगा मिल गया, इसका पावर हाफ. Omega is this entire thing raised to power half. And again omega upon 2 pi will give you frequency. So 1 by 2 pi times this. Option check कर लो, k plus rho a g, k plus rho a, there is no l, rho a g, k plus rho a g by m. This looks correct. K plus rho a g by m. Is that clear? If instead of m it was rho a l over here, then it will make again mass of the cylinder. So then it will be correct. Any confusion? Anyone? I'm moving to next question. Is there any doubt? Next question. A highly rigid cubical block A, capital A of small mass m and side length L is fixed rigidly onto another cubical block B of same dimension and low modulus of rigidity A, rigidity n, or you can say eta, क्योंकि options में eta लिखा हुआ है n की जगह. This is a mistyping. Eta such that lower face A completely covers, lower face of A completely covers the upper face of B. So B is down. एक second. There are two blocks. They are one over each other. A highly rigid block A. So this is block A. This is block B. B is modulus of rigidity is this, and the lower face of A completely covers the upper face of B. The lower face of B is rigidly held onto a horizontal surface. A small force F is applied perpendicular to one of the side. मैंने उल्टा बनाया diagram. Wait a second. There is issue in the diagram. ये दोनों उल्टे हैं. Wait. The lower face B rigidly held into horizontal surface. So this is like attached to over here. So this is my B and this is my A. Now on A, we are applying a force capital F like this. After the force is withdrawn, block A executes a small oscillation. So A starts oscillating. The time period of which is given by C. The thing is ki as soon as you give a push, what will happen that B will slightly bend like this. Now if we write modulus of rigidity, let's say this angle is theta and this displacement is x, this is x. So x is nothing but the side length was, what was the side length? L. So both are identical. So this is x is equal to L theta. What can we write about modulus of rigidity? Is equal to a negative of restoring force divided by F by A divided by theta. So F by A theta. So it is minus F by A. Theta is x by L. So x by L. So it is this. Now from here I am finding restoring force. So restoring force comes to be minus of A x eta divided by L. So this is restoring force and you just equate it to mass into acceleration. Mass into acceleration if it is performing oscillation is omega square x. X cancel out करेंगे and minus cancel out होगा तो we'll get A eta L m is equal to omega square. What are they asking? Time period 2 pi by omega. Omega is square root of this and eventually we get time period is equal to 2 pi by omega. So it will turn out L m by A eta. Area. Area is what? हमने area रखा नहीं. Area is basically area on which force is applied. So that is like pressure kind of thing. Force per unit area. So area is nothing but L square. Put at L square you get 2 pi. Area is equal to L square only because it's a cube. So 2 pi under root m by L eta. ऐसा option है m by L eta. D. Is that clear? D option is correct. Is there any doubt? I'm moving to next question. Give us the answer. Next question is one end of a long metallic wire of length L is tied. So this is length L is tied to a ceiling. The other end is tied to a massless spring of a spring constant K. The area, a mass M hangs out freely from the free end of the spring. The area of cross section and the Young modulus of the wire is A and Y respectively. If the mass is slightly pulled down and released, it will oscillate with a time period. So we have to again find the time period. Now see, this is an elastic wire, right? This is an elastic wire. So iska bhi like it also is, behaves as a spring. Let us say uska spring constant is K2. Let's find that K2 first. So for spring, if the expansion is X, force is Kx. So K is what? Basically force per unit length, right? Force per unit length. Let us stretch this by L. Then how much force per unit length is that? Let's find that. That will be our K2. So Young's modulus is defined as FL by A delta L, and delta L is small l only. So let us just find F by L, and that is YA by capital L, and this is my K2. Now there are two springs, like this is K2 and this is K1, K, and both are attached in a सीरीज बैनर. सो सीरीज में स्प्रिंग बिहेव्स, तो उसका इफेक्टिव क्या आएगा? सो टाइम पीरियड विल बी फाइनल टाइम पीरियड 2 पाई अंडर रूट m by k but k effective, and we just need to find k effective. So k effective of these springs is k2 upon k plus k2. Put the values and you will get your answer. So 2 pi under root m by k2. K2 is YA by L, YA by L upon K1 plus K2, that is K plus YA by L. L common आ जाएगा, so it will become M 2 pi under root M KL plus YA upon KYA. Is that an option? KL plus YA upon B looks correct. Is there any issue? Is it clear? Answer is B. I'm moving to next question. यहाँ पे अच्छे से explain किया हुआ है. Let me clear it first. Next question. Particle of mass m is executing oscillations. This is oscillation. There is a spell error. About origin on the x-axis, its potential energy is V is equal to kx cube, where k is a positive constant. If the amplitude of oscillation is a, then time period t is. What will be the time period? So, see. Potential energy is given as this. तो उन्होंने k निकाल लिया. K is V by x cube. Now, just a second. अब उन्होंने k का डायमेंशन निकाला है. तो this is potential energy and this is distance. So this is L cube. Potential energy is m L square t raised to minus 2. That is force का dimension. So now उन्होंने t के लिए बोला है कि let t depends on mass and length and k raised to power z, where k is this constant, okay, and length is nothing but like length is amplitude, this is distance, okay. So यहाँ पे उन्होंने basic dimension वाला formula लगाया है. They are just equating the dimensions. So time period का dimension, let it be m raised to power x, L raised to power y, I'm writing small y, and k raised to power z. Now k का डायमेंशन जस्ट डाल के टोटल एम एल टी करके दे डिड m का डायमेंशन एज 0, l का डायमेंशन एज 0 एंड टाइम का डायमेंशन इक्वल्स टू 1. सो दे गॉट द वैल्यू एंड इवेंचुअली दे गॉट कि t इज प्रोपोर्शनल टू a raised to power, l is amplitude, okay, amplitude. So t proportional to amplitude raised to power minus half, क्योंकि हमारा जो y है that is minus half. Is that clear? So t proportional to 1 by square root of amplitude or distance. Is that clear? डायमेंशन इक्वेट किया है उन्होंने फॉर्मूला डाल के. बेसिकली पहले k का डायमेंशन निकाल लिया एंड देन टाइम की डायमेंशन से मैच कर लिया. एंड दिस इज की लेट्स से कि m मास पे डिपेंड करता है, लेंथ पे एंड k के ऊपर. इज दैट क्लियर? Any doubt in this? Moving to next question. A mass m attached to a spring oscillate with a period 2 seconds. If the mass m is increased by 2 kg, the period increases by 1 second. Find the initial mass m, assuming that the Hooke's law is obeyed. So simple time period का formula लगाना है. Time period is equal to 2 pi under root m by k, and this is the one equation. And then time period is increased by 1 second. So that is t plus 1 is equal to 2 pi under root mass is increased by 2. So this is m plus 2, and spring is same by k. And first t is also given. This is 2 second and this is like 3 second. So just divide. You get 2 by 3 is equal to under root of m upon m plus 2. Solve this and you will get your mass. So 4 by 9 is equal to m upon m plus 2. So 4m plus 8 is equal to 9m. 5m is equal to 8. 8 by 5, that is 1.6 kg. B is the correct answer. Simple formula based question. Directly came into JEE. Is there any doubt? Any confusion in this? Anyone? Is it clear? Moving to next question. Next. Two masses m1 and m2 are suspended together by a massless spring of spring constant k. When the masses are in equilibrium, m1 is removed without disturbing the system. Find the angular frequency and amplitude of oscillation of m2. See, this spring is already pulled, right? And how much kx is there? Like if we just find initial expansion, then kx not, I'm saying it is like initial expansion. It is balancing m1 plus m2g. And if this was the initial equilibrium position, if m1 is released, right, m1 is removed, then there will be a new equilibrium position. So that new equilibrium position, kx will balance out m2g. So this x will be m2g by k. And this difference will become the new amplitude. So, and this from like origin, like let's say x is equal to 0 is somewhere over here. So from here, this is m2g by k, and this total is m1 plus m2g by k. You just subtract, so you get the amplitude. Amplitude comes to be m1g by k. Amplitude के option देखो, this is wrong, this is correct, this is correct, this is correct. So one option is removed. Next, let's talk about find the angular frequency. Angular frequency is 2 pi, angular frequency omega is under root k by m, and m is only the mass which is attached, which is m2 now. Wait a second. Just a second. This option is incorrect. यहाँ पे 2k है, and this option is now correct. Answer A. Is that clear? Any confusion in this? Anyone? See, omega depends on, omega is under root k by m, and this is mass which is attached. Now we have removed m1. This is just m2. And amplitude, I have told you, the equilibrium position and the new equilibrium position, the difference between them will be new amplitude. Is that clear? About new equilibrium position, it will start performing oscillation with this amplitude, with this angular frequency. Is there any confusion? I am moving to next question. A simple harmonic wave train is traveling in a gas in the positive direction of x-axis. Its amplitude is 2 centimeter, velocity is 45 meter per second, and frequency is 75 per second, that is hertz. Find out the displacement of the particle of the medium at a distance 135 centimeter from the origin in the direction of the wave at the instant t is equal to 3 seconds. just a second. So the equation of wave उन लोगों ने assume कर लिया है positive x direction में जा रहा है, that's why here is a minus. If it is moving in negative x, then यहाँ पे so it is a sin omega t and omega t, that is basically 2 pi by capital T into small t, and minus kx, so kx is basically 2 pi by omega or 2 pi by lambda, that is k, and 2x. So 2 pi they have taken common and they have written this equation. Now x, their amplitude is given as 2 meter, velocity, wave velocity is 45 meter per second, and frequency is given. Using these two we can find lambda. So v is equal to f lambda, we can apply and we can find out. So time period was already given 1 upon frequency, so 1 upon 75, that is time period. Basically omega निकालने की जरूरत नहीं पड़ी, and wavelength lambda निकाल लिया यहाँ से. Frequency was given, so lambda they have find out velocity upon frequency, so you get 60 centimeter. Put them everything in equation, where y and x are in centimeter, t is in second. So basically इस equation के अंदर अब हमें बस values substitute करनी है. तो to find out the displacement at a distance 135 centimeter, x की value रख दो 135 centimeter. Reason is this 60 is already in centimeter, or t is equal to 3 second, तो यहाँ पे just put t is equal to 3 second. Just put the values and solve for y. You get this, and eventually 450 pi minus 4.5 pi. एक second. यहाँ पे basically 450 pi is 2 pi का multiple. So you just get sin 2 pi plus minus theta is same thing, right? Sin 2 pi plus theta is sin theta only. And eventually negative बाहर आ गया, and you got this. Again 4.5 pi is 4 pi plus pi by 2. So sin 4 pi is again same thing, it's just same as sin pi by 2. So minus 2 into sin pi by 2, so you get minus 2 centimeter. First they found the equation, then they substituted the values. Is that clear? हम लोगों ने normal, अगर इतना ये सब में नहीं जाना है, you can directly go like this also. Omega is 2 pi by t, time period रखो, or you can just use 2 pi f, frequency रखो, and you get omega. K is equal to 2 pi by lambda. Lambda is what? V by f. So 2 pi f by v. Use this to find k. Just directly you will be able to find this equation, substitute all the values, and eventually you will be able to find the position. Is that clear? इसके अंदर में उन्होंने 2 pi के मल्टीपल का यूज किया है, that's all. दो जगह पे sin 2 pi, ये वाला फॉर्मूला, sin 2 pi plus theta plus minus theta is equal to sin of plus minus theta. That's all. Is that clear? Any confusion in this? I'm moving to next part. Next question. In progressive wave, motion is y is equal to a sin 2 pi by lambda vt minus x. Velocity of the particle is. So they are just asking particle ka velocity. See, this is a wave and particle velocity is this y है ना, तो dy by dt is particle का velocity. So you just do that, dy by dt, इसको time के respect में differentiate करना शुरू करो. So dy a sin 2 pi by lambda vt minus x, and इसका time के respect में differentiation. So what do we get? A remains here, partial differentiation कर दो time के respect में, del y by del t. So you get a sin 2 pi by lambda, and vt का just v बन जाएगा minus vt minus x. एक second, what I am doing, 1 second. इसका टाइम के रेस्पेक्ट में डिफरेंशिएट करेंगे. सो a sin का cos बन जाएगा cos pi by lambda vt minus x, एंड बाहर से एक v और बाहर आ जाएगा. Now get dy by dx also, because in all the terms it is also there. So dy by del y by del x, basically with respect to x, start differentiating it. So what do we get? A, then sin theta का cos theta, एक सेकंड मैंने डिफरेंशिएशन कुछ गलत किया है क्या? V into 2 pi by lambda will also be there, 2 pi by lambda. This constant will come out and x के साथ वाली कोई चीज बाहर नहीं आएगी. This is dy by dx a cos 2 pi by lambda vt minus x into 2 pi by lambda. 2 pi by lambda will come out और एक minus भी आएगा. So now this is my इसमें से सब्स्टिट्यूट करना शुरू करो. 2 pi by lambda cos this entire thing, 2 by lambda a भी है, and cos of this entire thing is dy by dx. So सिर्फ v बच गया, and this is negative of dy by dx. So this is the answer. This is particle velocity, this is wave velocity into negative of dy by dx. Answer is B ठीक दिख रहा है और तो कोई ऑप्शन मैच नहीं कर रहा. Is that clear? B is the answer. This is a standard formula also. V dy by dx. There is an issue in with the option. Option में एक यहाँ पर negative होना चाहिए. Then this will be answer. Is that clear? V dy by dx of negative of V dy by dx is the answer. Moving to next question. A string of mass 2.5 kg is under a tension of this. The length of the stretch string is this, 20 meter. If the transverse jerk is struck at one end of the string, how long does the disturbance take? How long does the disturbance take to reach the other end? So basically, you just find wave ka velocity, that is wave velocity is at T by mu, mass per unit length. So mass of this string is 0.5 kg divided by length is 20 meter, right? So that is this one. यहाँ पे find out क्या हुआ, and tension you just put 200. So you get wave ka velocity as 40 meter per second. Now this is wave velocity, so you just find distance divided by velocity is the time period. So total length traveled for this, like they are saying कि यहाँ से हम लोग wave start कर रहे हैं, how much time does it take? So time is just distance, which is nothing but length, divided by speed, which is 40, so it is just 0.5 second. Is that clear? Here we have used this formula. Velocity of wave inside a string is under root T by mu, mass per unit length. This is not mass, this is mass per unit length. Moving to next question. A 5-watt source sends out waves in air at frequency 1000 hertz basically. Deduce the intensity at a 100-meter distance assuming spherical distribution. If V is equal to 350 meter per second, rho is equal to 1.3 kg per meter cube. Deduce the displacement amplitude. So हमें amplitude निकालना है और intensity निकालनी है at a distance of 100 meter. So first intensity is power per unit area. So power, which was 5 volt, originate from the source and it is distributed in this entire area. This distance is 100 meter. So area is 4 pi r square, where r is 100. So 4 pi r square. So 5 watt divided by 4 pi 100 square. You get the intensity. This is intensity at this point, and it is directly proportional to, inversely proportional to square of the distance from the center. Now amplitude निकालना है, उसका formula है directly. Intensity is equal to 2. ये intensity का formula है, इसमें से A is the amplitude. So we just use this intensity proportional to amplitude square a lot, but intensity का formula you should remember. So 2 rho pi square n square and a square. So you just put the values. So we just did a square root. So pi and n came out. N is the frequency. Now n is 1000 per second. Intensity we have already found out, 4 into 10 raised to power minus 5. Density was given 1.3 and wave velocity was also given. Put all the values and you get amplitude as 6.67 into 10 raised to power minus 8 meter. Is that clear? Formula based question. Once you know this formula, then it will be formula and also it will take time. Is it clear? Moving to next question. In an experiment, it was found that the string vibrates in 3 loops when 8 grams were placed on the scale pan. What mass must be placed on the pan to make the same string vibrate in 6 loops? Neglect the mass of the string and the scale pan. So basically, it is vibrating in 3 loops. So here we can say, we can find the lambda. See the length of, let us say length of this string is L. What can we write about L? That 3 lambda by 2 is equal to L here, and then lambda can be found out 2L by 3, and B is equal to F lambda, just apply that, and V is equal to under root T by mu, and again V is equal to under root T by mu. Mu same रखना है और सिर्फ टेंशन चेंज करना है. टेंशन is mg and initially it was 8 gram, right? So V is equal to under root 8, it is 8 grams, so 8 into 10 raised to power minus 3 into g is again 10, divide by mu, that is mass per unit length, I'm keeping mu only, and is equal to frequency f and lambda 2L by 3. Now, next case is saying what mass must be placed on the pen to make the same string vibrate in 6 loops. So 6 loops करने तो what will happen? That will be 6 lambda by 2 is equal to L. तो यहाँ से lambda becomes 2L by 6. So if I want 6 over here, just a second, I want 6 over here, तो मुझे mass के साथ क्या करना पड़ेगा? Mass has to, so I'll just write, let's say new mass is mg, and let's say m gram, new mass is m gram, so m into 10 raised to power minus 3 into g divided by mu is equal to frequency f into 2L by 6. Divide both the equations, you get square root of m by 8, everything else cancels out, is equal to frequency 2L, everything cancels out. M by 8, m by 8 is equal to 3 by 6, that is half. Square it. So m by 8 is equal to 1 by 4, 4 say 2, m is equal to 2 gram. Saying what mass must be placed on the pen to make the same string vibrate in 6. The answer is 2 gram. C option. Is that clear? Is there any confusion? I just says कि 3 की जगह loop double करने के लिए basically wavelength should be half, and wavelength के लिए frequency remains same, so velocity will also become half, and उसके लिए tension को basically 1/4 होना पड़ेगा. Next question. Length of a wire. The length of wire between two ends of a sonometer is 105 centimeter. Where should the two bridges be placed so that the fundamental frequency of 3 segments are in the ratio 1:3:15? So हमें सिर्फ distance निकालने की, basically I am dividing my string in 3 parts, okay, and this is the string. I am placing my bridge over here and here. Let's say this is L1, L2 and L3. Now this is the same string, right? So from the law of length, we can say N1 L1 is equal to N2 L2 is equal to N3 L. So here the frequencies were given, right? So we can just say कि frequency इन्होंने basically L1 by L2 निकाल लिया is the ratio of N2 by N1 and that is 3:1 and again L2 by L3 निकाल लो that is the N3 by N2 so that is 15:1 इसमें अभी कॉमन रेशियो करके L1:L2:L3 निकाल लो सो यहाँ पे 1 है तो इसको 15 से मल्टीप्लाई कर दो so it is 45:15:1 now you get L1 L1 is basically 45 divided by total sum of their ratios which is 45 plus 15 that is 60 to 61 into total length 105 plus 105 centimeter long, right? So you'll get your answer. कुछ गड़बड़ किया है मैंने second L1 by L2 is 3:1 and again L1 by L3 is 15:1 and कुछ गड़बड़ है ओके यहाँ पे 1 नहीं आना चाहिए सी माय बैड मैंने L2 by L3 किया है उन्होंने क्वेश्चन में L1 by L3 किया है सो इट इज 15:3 and that is 5:1 और अभी इसको इक्वेट करने के लिए I'll just multiply with 5 that is 15:5:1 just a second that is 15:5:1 और यहाँ पे अब L1 निकालो तो 15 divided by 21 into 105 so this is 5 and you will get 75 centimeters. You can find L2 that is 25 and you can find L3 which is 70. They were asking all lengths. So 75, 25, 5. Just a second. Asking कहाँ पर प्लीज करना चाहिए तो फर्स्ट वाला 75 पर सेकंड वाला स्टार्ट से लेके 100 तक so answer looks at C C is the correct clear issue in this hello hello was that last question audible was even audible or like is this question clear to all of you I was disconnected for like I don't know why okay let's end the class this question is clear to all right हमने बस ये फॉर्मूला यूज कर लिया है लॉ ऑफ लेंथ दैट्स ऑल because same tension is there so we can use C. Frequency of vibration is L which is V by 2L and law of length says ki this L will come over here so we will just say velocity is same because velocity ka formula is under root T by mu. Mu is same and tension is same so V is same so we can just say N1 N1 is equal to N2 L2 eventually we can find the ratio of length and we can split the total length in ratio. If there is any confusion, ask. Otherwise, I am ending the class. Ending the class. Bye bye. Take care.